questions using R. This video is brought to you by Analytics Finishing School. Let's get started. Okay, so R is a programming language software environment for statistical computing and graphics supported by the R Foundation for Statistical Computing. So it's all known to most of the people out here that R is actually used as a programming language, and using R you can do a great deal of data mining and data analytics. In this course we're going to be studying this platform / this language in detail, along with the packages that we'd probably be using. R is a GNU package. The source code for the R software environment is written primarily in C, Fortran, and R. Okay, so the innermost inbuilt packages such as the iris data set, the sum, average, the stat functions, and other important functions that we will be evaluating and using in R are actually written primarily in C, Fortran, and R. When I say they're written, basically I'm trying to say the algorithms are written in these programming languages. R is an implementation of the S programming language combined with the lexical scoping semantics inspired by schema. So just for someone who's not really heard about S programming, R is actually an advanced, encapsulated, abstracted version for a programming language which was first discovered, called as S programming. The refined schema, we're going to be discussing schema further details in the course, but just for now, the schema or the dataset series of these framework within packages is slightly modified in R, that thereby supporting object-oriented programming principles and paradigms a bit more. So that is why people are sort of starting to shift from S to R. R and its libraries implement a wide variety of statistical and graphical techniques, including linear and non-linear modeling, classical statistical tests, time series analysis, classification, clustering, and others. So in R, you sort of find a lot of packages which can help you do statistical computations. As you can see, you can sort of do linear and non-linear modeling. Just to give a quick brief about what exactly linear and nonlinear modeling is. Let's say if you write an equation y equals ax plus c. So in this equation, we've studied in our basic linear algebra that this is an equation of straight line. And this straight line can actually be used to demarcate two kind of separations between entities, right? Probably during our sessions, we're going to be studying in detail that such problems are called as classification problems. And if you are actually able to classify the data set that you've obtained in series of 2 to 3 on the basis of curve, the equation so form is quadratic, which is nothing but in the form of ax squared plus bx plus c. Okay, so basically R has packages using which you can create those linear mathematical equations which can help you create a model and thereby predict some important information that you might be interested in. Okay. Next thing that you can probably do with R, as I've just stated in the PPT, is classical statistical tests, the R test, the chi-square test, the entropy gain, enthalpy, and all those kind of tests can also be performed with R. Time series analysis, this is a specific kind of reinforcement learning algorithm structure in which you see how the data set actually given to you is changing with respect to time. And sometimes, actually most of the times, if people come from the physics background, they'd already be knowing that time is actually a very important parameter which is sort of generally placed on x-axis, given it is always independent. So time series analysis are a bit slightly higher version and advanced version of our programming packages, but we are also going to be covering those in this course and further courses that we will be having. Okay, classification, clustering, and others. I've already explained just a few minutes back what exactly classification is. Classification is nothing but just to classify sets on the basis of certain similarities. Let's say either you're going to be, either your customers are going to purchase the computer or not, or either it is going to be sold in the market or it won't, right? So these discrete values wherein you're trying to understand your customers' purchase behavior, or any discrete values that you try to be obtaining is actually coming under classification. On a very bigger picture, it's more like you're classifying things on the basis of certain properties they share and then categorizing them, okay? Clustering is coming more under unsupervised learning actually. So in clustering, you do not already have the attribute that you're really interested to know, but you sort of cluster the data sets which is given to you on the basis of properties they share, the similar properties they share. You don't have a point of demarcation, okay? Let's say in the first example I just gave, we were given a problem statement that figure out whether the customer is actually going to buy a computer or not. In case of clustering, you don't have such kind of problem statements. You just have the data set and you're supposed to cluster them on the basis of similarities and differences. Recommendation engine are a kind of clustering systems, okay? So wherein you can sort of recommend people by just sort of matching them where exactly they fit in the cluster. I mean, what kind of characteristics or attributes they share with other people in those clusters and thereby predicting them, okay? Clustering can also be sort of understood very well from the periodic table, right, guys? We've been taught that elements from, the metals are supposed to be showing properties which are very similar to metals, and non-metals are supposed to be showing properties which are very similar to non-metals, and so on and so forth, right? So clustering is a good example in such cases. Next point, R is easily extensible through functions and extensions, and the R community is noted for its active contributions in terms of packages. Voila! Good news, right? So all the people who are interested in sort of contributing for open source structures in R, they're free to do it, given the community is really active, and you can help build algorithms and data structures which can really improve R's overall packages, okay? We are going to be covering some parts as to how we can do this in our course, which is going to be an extra add-on, and it'll be a feather in the pearl of your resume, okay? The third part is, due to its S heritage, R has stronger object-oriented programming facilities than most statistical computing language. I think this needs no mention specifically, as I've already mentioned a slide before that R is the advanced version of S, and it's sort of the best ever object-oriented programming language amongst most of the data science packages that you'd be using, okay? So that was the general intro about R. Let's just see what we're going to see in this course, okay? So the course starts with Introduction to R language. In this, we're going to cover the data types in R and their uses. We're also going to touch upon the built-in data types like the iris dataset. We're also going to be capturing some information about the built-in functions, how you can do the subsetting of methods, and then how can you be summarizing the data, okay? Data manipulation in R. In this subsection, we intend to cover how should you be cleaning the data, functions, and how are you going to be using the function to inspect your data. Control structures, sorting the information, sorting your data, merging and appending data. Most importantly, in this section, we are also going to teach you how exactly should you be looking at the data set which is given to you and make some judgmental analysis, which is sort of pretty unique to this course, okay? It's very important, right? Like as a data scientist, you have some kind of a judgmental information when the data is actually being provided to you, correct? So that's also going to be the focus of this section. Data import techniques in R. In this section, we intend to sort of discuss how can you import data from spreadsheets, text files, and all sorts of possible places, including PDFs and JPEG images. So for the curious heads here, import data from other statistical formats like SAS7, DAT, and SPSS. Packages installation used for database import, like database import OLEDB JDBC connections in R is not direct. You're supposed to have a lot of dependencies installed, and it takes a lot of while to actually get cracking with those things. So in this section, we're going to be covering those parts in detail. ODBC, as I've already stated, SQL queries, one of the best queries to actually query your database and then fetch the results in R, and web scraping, okay? Data visualization in R. The important thing that we intend to cover here includes graphical functions, table plot, histograms, box plot, customizing parameters, GUI, reducer, and R commander. Okay, so just don't get bothered if some of these terms are not very clear in this introductory video. The only intention is to just let everyone know what exactly should they be expecting from this course in general, okay? Sorry about that. The next section would be just an overview and introduction about analytics. So you'll just get a hold of what exactly analytics is, what are its applications, what are the different tools you can probably use, and what exactly can you be expecting when you hear the word data analytics, okay? Data processing, in this section we intend to cover how can you clean the data, how should you be handling missing pieces of information, how will you be detecting the outliers, how are you going to be transforming variables. Again, if all of this is not something you guys are familiar with, it's totally okay at this point of time, because while we're going to be studying this course, we're going to be capturing all these information in a lot of detail, and we would be highlighting each of these points with all of the graphical computations and equations involved in understanding these things really well, okay? So please do not get worried if some of these or most of this is not very clear, okay? Next is fundamentals of statistics. In this section, we're going to be just giving an overview of different statistics that we would be needing while data analytics and mining courses. We include statistical tests, we include probability and distribution, we also include measures of central tendency, mean, median, mode, etc. that we would be needing during this course series, okay? So it's okay if you guys do not have a statistical or mathematical background. As you can see, we are covering a lot of variety of stuffs, okay? Then we're going to touch upon segmentation techniques, which will have a few algorithms in it. Excuse me, again, sorry about that. Clustering algorithm, hierarchical clustering, k-means clustering, distance measuring methods, and stuff like that. Well, this course seems to be a bit lot, right? Yeah, I can understand. Okay, so next thing we intend to cover is predictive modeling through regression. We'll touch upon regression, we'll see how we can predict models through regression. What are the best cases, what is statistical computing, machine learning algorithms under this subsection as well. In this, we are also going to cover decision trees, how we can use R packages to actually build one. We're also going to learn techniques of ensemble learning. This will include the card, trade, case study, decision rule, C4.5. Ensemble learning, we're going to cover two very important algorithms in ensemble learning, machine learning algorithms, which is basically random forest and bagging and boosting. We're also going to cover the original paper of the random forest, which was first discovered, and we're going to be seeing how exactly this can be improvised further and be applied to Bayesians and deep neural network analysis, okay? We're going to close the complete session through a final case study. The case study subject will actually be brought upon from some of the major Fortune 500 companies, and you're going to be competing on some of the world's biggest platforms to actually prove your skill set. So stay tuned, and I look forward to everyone to join the course, okay? Thank you.